All right, welcome to our Chapter 4 review, Industrial Print Reading for our Power Transmission course. And I'd like to firstly say that I think this section of the book is really good. It's a great overview. I have provided you additional material to dive into a couple of these areas a little bit more. But the book itself does a great job of covering these at a pretty high level. The book includes a lot of stuff without explaining it deeply because this is just meant as an introduction, and that's okay. I'm going to dive into just a couple of these as I read through my book review to give you a little bit more of an understanding of them. And the last section in the book, which is welding, we've got a whole course for welding, and welding schematics are in that course. I'm not going to spend a lot of time on the welding schematics, so we're going to talk about all these other industrial print reading and hit on the welding last. So let's change my camera to my document camera. Chapter 4 starts on page 67. We're going to do all these objectives. I'm not going to read them to you, except we're going to hit on the welding very lightly, which is the last objective. Okay. Your first section in here is on dimensional drawings. And I have provided you a good video on dimensional drawings. And probably as a maintenance tech, dimensional drawings are your single most important thing you're going to have to be able to do accurately and cleanly. Not to say that you have to learn how to use AutoCAD, but you should be able to sketch up parts that need to be fabricated. This is a very important skill in mechatronics, anywhere in industrial maintenance. It's a very important skill. And pretty much in life, anytime you want to have somebody make anything for you, it's good to be able to describe it in a way that's extremely clear, and we can follow up on this. Now, I did a little bit of a demonstration of how to use PowerPoint or Google Slides to do this, so I urge you to do that in PowerPoint or Google Slides, or get yourself a good ruler and do it using the techniques shown here. The one thing I'm going to add to this is a concept called implied tolerance. Anytime you've got a measurement in here, you notice in here they have a measurement of the distance from the inside of that flange to the end of the part, which is 1.82. And they don't say the unit of measure. A lot of times you have implied unit of measure. If it's all English, it'll say, you know, unit of measure, standard, inches. But usually you have a unit of measure on there. It should be inches shown on here. And there's an implied tolerance. The implied tolerance is if I put 2 decimal places, that implies my tolerance is to those 2 decimal places. In fact, my applied tolerance is 0.005. So it's like half of the next decimal place. Plus and minus 0.005 is an implied tolerance. So the more decimal places you show, the more tolerance you're implying. So if you do 1 decimal place, that's implying that you only have 0.05 inch plus or minus accuracy requirement and so forth. So when you hand someone a part, don't give them a gazillion decimal places, right? 4 or 5 decimal places. Give it to them in the implied tolerance that you want. So that's your basic dimensional drawings. And the book spends a paragraph on that, but there's a lot more to it than that, which is why I presented you that video. The second section here under mechanical drawings is schematics, okay? And schematics covers a broad number of drawings. Hydraulics and pneumatics are schematics that you're going to see many times and also critical for this course. So I've given you, once again, a little video to show how these drawings work. the purpose of this course is to not get into what all these different little symbols mean, but to give you an idea how these drawings, they're not to scale. They're not meant to be any kind of physical layout. They're meant to show how parts are connected together from a controls and a basically functional standpoint. And so I gave you guys a little video with a little animation showing how these symbols can animate if you get the right software to give you an idea of how they operate. These symbols are fun and interesting. You're going to see the same sort of concept for all the different drawings out there, all the different schematics out there. They are symbolic representations of the physical device. And you kind of have to squint your eyes and scratch your head a little bit, but they actually are set up to be representative of how that device really works. And I'm not going to dive into the details, but just to give you a for instance, the top one here is a cylinder. And it looks like a cutaway view of in this case, hydraulic cylinder. And you can see you got a center shaft coming out the right, and you've got a piston on the back end of that center shaft, and you've got a cylinder housing, and then you've got a connection on the back end of the housing for pushing hydraulic fluid into the back end of the cylinder, and you've got a connection on the front end of the housing for letting fluid run out of the front part of the cylinder. This is a sort of a generic, not an actual representation of a hydraulic cylinder, but it's a kind of a stylized symbolic view, which sort of represents how that cylinder really works. And all of these symbols have that sort of approach to them. They're stylized views to give you an idea, just by looking at that symbol, how that thing works. And that's true for many hydraulic and pneumatic, which is why hydraulic and pneumatic drawings are often more intuitive. When you get into electrical, you kind of need to know, because they're more stylized, you kind of need to know what that symbol means. Next drawing type is exploded view drawings. And they are, I mean, if you ever assembled furniture or followed any assembly procedures, they tend to be used for how you take things apart or put things together. Pretty obvious.